So this is a FET characteristics experiment. The model number of this trainer kit is EDC-06. So to perform the drain and transfer characteristics of FET, so whatever the requirements is for doing the two experiments are provided here. So it is required two variable power supplies. So here it is a 0 to 20 volts variable power supply. By using this knob, you can vary the voltage from 0 to 20 volts. And here the negative voltage is provided. So here it is also negative is also up to the 20 volts. So you can vary the negative voltages from 0 to 20 volts by using this knob. Okay, these knobs are called as a potentiometers. Okay, so these power supply, what are the 20 volts is there, that will be generated internally. So just you need to connect the meters and do the experiment. So to perform a drain characteristics, okay, so to perform the drain characteristics, we need to connect a voltmeter and a meter, that is a current meter, and here it is an voltmeter. So this side meter is a voltmeter, so we can connect this voltmeter to across this potentiometer. And here we need to connect the current meter here. So connect this multimeter is working in a current meter. So the range is put it in 200 milliamps. And here the voltage range is a 20 volt, 200 volts range. Or otherwise you can put it in a 20 volts also. And connect this voltmeter to the here. So before connecting this, we'll make the connection of this current meter. So here in a current ampere meter, so the polarity is also mentioned. So connect the negative terminal of the multimeter here and connect the positive terminal of the multimeter to here. Okay, and the next, connect this voltmeter again, another voltmeter, that is a VGS voltmeter, negative terminal to here and positive will be here. Okay, so this is a trainer kit manual. So in this manual we have the configuration, how to total circuit diagram, and the next one the pin identification of this FET BFW10 or BFW11, and the procedure how to do the experiment, each step is provided. So here to perform the drain characteristics, this is a main tabular column. So here the drain characteristics, put the VGS first, we need to set the VGS to the 0 and apply output, that is a VDS, vary the VDS voltage and note down the current at this point for each step. So let's do this one, first one, drain characteristics. Just turn on the kit. Before turn on the kit, make it that this potentiometer should be zeros. Okay, 0 volts, not in a 20 volts. Just turn on the kit, and here you can observe every meter is having the 0 reading. Okay, so first set the VGS is 0. So this is a VGS. So this is a VGS meter. It is in a 0 condition. And now vary the VDS voltage and observe the current reading. Okay, so slowly vary the VDS voltage. So like that. So I'm putting 0.5. First of all, I'll take this a point linearly, 0.5 like that. So for the 0.5, we have get the current as a 1.9 milliamps, and increase for the 1 volt. Okay. Okay, this is a 1 volt, and note down this 3.2 milliamps, and linearly I'm increasing to the 2 volts. Like if you want, you can go with the 1.5 and 2 volts. Okay, and the next one, when it is in a 2 volts in a VDS, when VGS is 0, the output is 4.3 milliamps. Now go to the 3 volts. I'm going with the 1 volt incrementer. If you want, you can go with the 0.5 variations also. So observe, previously it is having 4 point something, still it is a 4.6 data. So if you increase this, so see the if it is a 5 volts, still it is a only point wise increment, so that we can understand that whenever we are increasing the drain voltage, so we are getting the constant current for this drain characteristics. So see here, so almost constant. Okay, so when it is a VGS 0, it is almost constant. So if you vary with the up to the 15 to 20 volts, so you will get this constant current. And to do the next one, just make it as a 0. And to do the so to do next one, Okay, so here we need to put the VGS as a minus 1 volt and apply the VDS and note down the current readings. So this is a VGS and vary this potentiometer and set it for 1 volt, minus 1 volt. Okay, so it is 1 volt and do the procedure same thing previous one, just increase the VDS voltage and note down the current. So I am going with the 1 volt. Okay, for the 1 volt we have get the 1 milliamp and I'm going with the 2 volts. 2 volts we have get the 1.2. Okay, so let's see this 1 volt we have 1 milliamp. For the 2 volts it's just 0.2 increment. So like that if you go with this 5 volts, okay, if you see this in a 8 volts. So if you observe I'm increasing linearly to the 9 volts, still it is a 1.4 only. There is a linear change when it is in a minus 1 VGS voltage. So this is a constant current for this 1.5 is a constant current for this VGS is a minus 1 voltage. And note down these two readings. So note down these two readings in this tabular column and if you plot this with the help of the graph, so you'll get the curves like this. So whenever we apply whenever VGS is a constant, actually we need to put here as a VGS as a constant, that is a 0 and minus 1. So whenever a VGS is a 0, you will get the maximum current, and whenever VGS is a minus 1, you will get the less of below of this minimum current. So vary the VDS and observe the current and note down those points and graph a plot for that. So that is a drain characteristics of the FET. Okay, so let us see the transfer characteristics of the FET. Okay, so to do the transfer characteristics, we need to apply a VGS is a VDS is a 2 volts. Not only for the 2 volts, you can go for the 4 volts or 5 volts also. First, put the VDS as a some constant voltage and observe the VGS and vary the VGS constantly, linearly, like a 0.5 or something, and go for the ID. Note down the current in a milliamps, ID, drain current. Okay, so to do this experiment, first of all, we'll make the both the potentiometers will be 0, 0. Now we need to apply this is a 2 volts as a VGS. Okay, so for 2 volts the VDS. Okay, so I'm putting this one as a 2 volts. Okay, I'm setting this. So 2 volts. When it is in a 2 volts, we are getting the current as a 5 milliamps. Okay, so now vary this VGS linearly and note down the variation in the current. So if you see this, I'm giving the 0.5 as a minus 0.5. So you'll get the current as a 2.9. Previously it is in a 5. So now it is in a 3.0. So note down this current readings and variation of this voltage. Okay, and one more thing, whenever you are changing from the observe here, so I'm giving the 2 volts. So note down this current. Whenever I'm changing it to the 1 volt, for example 1 volt, you can see here it is changing 2 volts to the 6 volts. So just to drop it this to the 2 volts. Okay, and note down the current and increase here. Okay, so that is a 2.2 volts and just decrease this actually. Okay, 2 volts and note down this current. So now the current is 0. So whenever VDS is a 2 volts and vary the VGS and note down the current. So for example, if it is a VGS is a minimum, it is completely 0. So whenever it is in a 2 volts, okay, you will get the maximum current. So this is a maximum current we are putting, that is a 2 volts. Okay, it is a 5 milliamps. If you vary the VGS, the voltage of the 5 milliamps is continuously decrease this voltages whenever we are increasing the VGS voltage level. If you plot this for two different voltages, for example, if I am taken as a 2 volts and you can go with the 4 volts also. If you plot the diagram for this, so this is a starting point of the VGS. Okay, that is a whenever it is a 0 point, okay, VGS, so you will get the maximum current. Okay, so whenever we are linearly increasing the voltage of the VGS, so the current will be linearly dropping. So at some point it will be met in this VGS line, that is a completely zero. So this characteristics is called a transfer characteristics of the FET, okay, field effect transistor.